Have you ever imagined a highway made out of bamboo? It may sound impossible, but it has become a reality in Indonesia. The Semarang Demak Expressway is the first project in the world to use more than 10 million bamboo poles to reinforce weak soil and complete the road surface. Instead of relying entirely on steel and concrete, Indonesian engineers chose bamboo as a natural, sustainable, and cost-effective solution. More than 1,500 skilled workers directly took part in installing a massive bamboo mat system beneath the roadbed, an area once considered extremely challenging to construct due to its location right next to the Java Sea. In this video, join Mandarin Tech as we explore how this seemingly impossible idea was turned into reality, and why bamboo is emerging as the building material of the future. The northern coastal area of Java Island has long suffered from dozens of floods every year, with water volumes reaching tens of millions of cubic meters, inundating the entire downstream region within just a few hours. Therefore, the Semarang Demak project was created not only to serve transportation purposes, but also to act as a natural sea barrier, protecting thousands of households from the risk of flooding. The entire route is 26.95 kilometers long, divided into two sections: Semarang Sayung, 10.64 kilometers, and Sayung Demak, 16.31 kilometers, with a total investment of 16.8 trillion rupiah. The Sayung Demak section was officially opened in February 2023, while the Semarang Sayung segment, where the bamboo mat system is being implemented, is still under construction and expected to be completed by early 2027. Compared to other ground stabilization technologies, the bamboo mat is considered the most cost-effective solution, while providing a durable and environmentally friendly structure. As a natural material, bamboo causes no pollution and can be sourced locally without affecting the marine ecosystem or ship operations. Indonesia, a country that possesses up to 162 species of bamboo out of a total of 1,139 species worldwide, has an abundant supply, ensuring that this large-scale infrastructure project can operate sustainably for many decades to come. Before being put into use, each bamboo pole must undergo strict testing procedures to ensure its mechanical strength and long-term stability under the influence of seawater. Two common tests are applied: the transverse tension test, to measure torsional and tensile strength, and the perpendicular bending test, to evaluate elasticity and the ability to recover after deformation. Only bamboo poles with a minimum diameter of 10 centimeters, a straight length of at least 8 meters, and an age of 3 years or older meet the required standards for use. After passing the rigorous inspection process, the qualified bamboo poles are transported to the construction site, where they begin their second journey, becoming the foundation for a highway built over the sea. The bamboo is driven vertically into the soft ground, functioning like stakes. Every 7 bamboo poles are tightly bound together to form a large bamboo pile. These piles are driven into the ground at intervals of about 1 meter and can extend up to 150 meters wide. As for the bamboo rafts, the bamboo poles are arranged and tied together, then installed by laying them on top. At each end of the bamboo piles, they are securely fastened to the bamboo rafts with ropes according to the original design. Once installed, these bamboo mats gradually sink and become part of the coral reef, helping to reinforce the underwater structure. The next step begins: laying the geotextile fabric. This layer acts as a separating and load-distributing membrane, preventing sand from seeping into the gaps between the bamboo mats while stabilizing the surface before the next layer of material is added. The fabric is evenly spread across the entire 150-meter-wide surface, continuously connected between sections to create a uniform and durable technical cushion. After the geotextile fabric layer is completely secured, the next stage begins with the arrival of massive sand dredging vessels off the coast of Java. To form the foundation surface of the expressway, high-capacity dredger ships are deployed to pump sea sand over the entire bamboo mat system. The specialized vessel used in this stage is the trailing suction hopper dredger, a ship equipped with suction pipes located beneath its hull, capable of reaching the seabed to extract sand and store it in onboard hoppers. From there, the sand is sprayed onto the surface of the bamboo rafts through a special conduit, covering an area of more than 150 meters. The total length of the bamboo raft and sand foundation extends up to 6,000 meters, equivalent to 6 kilometers along the highway. This process is repeated continuously. One layer of bamboo, one layer of sand, until reaching the 17th layer, creating a solid foundation that is both highly load-bearing and flexible enough to adapt to the rough marine terrain. To shorten the consolidation time of the soft soil foundation, engineers use vertical drains, strips of drainage material inserted vertically into the ground. They function like conduits, allowing water within soil pores to escape quickly to the surface instead of being trapped inside. When the sand layer above exerts compression pressure, the water is forced upward along the drains and discharged, enabling the soil foundation to stabilize rapidly. As a result, the consolidation rate increases several times, allowing the project to reach the required settlement level in a much shorter time, ready for the road surface construction phase. From this point onward, the construction process proceeds similarly to conventional expressways. The road foundation system is formed by multiple overlapping layers, each serving a specific function. The subgrade, usually compacted natural soil, in this project is replaced by alternating layers of bamboo and sand, acting as the main load-bearing foundation. Next comes the sub-base course, made of crushed stone to increase load capacity and prevent soil from being pushed upward. Above it lies the base course, composed of granular material or bituminous mixture, which helps evenly distribute pressure from the road surface. Finally, the surface course, the layer directly in contact with vehicles, is made of a mixture of bitumen and mineral aggregates, ensuring a smooth, durable, and wear-resistant pavement. From the highways over the Java Sea to the skyscrapers of Hong Kong, the journey of bamboo continues, evolving from a humble material into a structural pillar of modern architecture. Hong Kong, the forest of steel and concrete with more than 9,000 skyscrapers, is a city that has nearly twice as many high-rise buildings as New York and 3 times as many as Shanghai. Yet amid this dense urban landscape, it is easy to spot scaffolding frames woven from bamboo surrounding the buildings. Unlike the rest of the world where metal scaffolding dominates, Hong Kong remains loyal to bamboo scaffolding, a construction technique with a history spanning hundreds of years. Before bamboo is brought to the towering skyscrapers amid the concrete jungle, it must go through a meticulous selection process where only the finest poles meet the standards for construction use. The selected bamboo must be between 3 and 5 years old and air-dried for at least 3 months to achieve maximum mechanical strength. Each pole can be reused up to 3 times before becoming warped or losing its flexibility. This selection and treatment process is the key factor that determines the overall safety of the entire scaffolding structure. After passing the strict inspection process, the qualified bamboo poles are transported to construction sites where they begin a new journey, becoming the framework that surrounds thousands of Hong Kong's skyscrapers. Bamboo scaffolding wraps around buildings from the ground to the very top, forming an intricate lattice stretching high into the sky. This system can be both lightweight and strong, as long as it is assembled with precision. 2 types of bamboo are commonly used: thick bamboo, moso, for load-bearing sections, and smaller, lighter bamboo, guadua or golduk, for frame connections. All joints are manually tied using nylon knots, a skill that takes years to master. In certain areas, metal supports are added to increase stability. Thanks to its flexibility, bamboo scaffolding can wrap around balconies, curved facades, and even suspended architectural structures. While in the past, scaffolders used to climb dozens of stories without any protective equipment, today Hong Kong law strictly requires safety harnesses, helmets, gloves, and non-slip shoes. Although durable and flexible, bamboo is not uniform in size or shape, which makes construction work require extremely high craftsmanship. Every joint is tied manually by hand, and even the smallest mistake can affect the entire structure. The demanding techniques and the lack of skilled successors have caused the art of bamboo scaffolding to gradually disappear in many places. Except in Hong Kong, where this green material is still celebrated as a symbol of craftsmanship and Asian identity. Today, bamboo is regarded as the green material of the 21st century, thanks to its superior mechanical properties and rapid renewability. With tensile strength greater than steel, bamboo can withstand high loads while remaining lightweight, flexible, and easy to work with. In contrast, steel production generates a massive amount of greenhouse gas emissions, as it requires burning large quantities of fossil fuels such as coal and oil. Not every country has the capability to develop a large-scale steel industry, which significantly increases both costs and environmental impact. Bamboo offers a different path: locally sourced, low-cost, and highly sustainable. In tropical regions, bamboo grows quickly, is easy to cultivate, and requires minimal maintenance. Therefore, bamboo is not only a building material but also a symbol of sustainable architecture for the future. Today, bamboo is not only used in construction, but has also become an environmentally friendly material for a wide range of consumer products such as straws, chopsticks, toothbrushes, cups, spoons, baskets, and decorative items. Thanks to its strong longitudinal fiber structure, lightweight, and natural moisture resistance, bamboo can effectively replace plastic, a material that has caused severe global pollution. Each bamboo straw or pair of bamboo chopsticks may seem small, but they play a vital role in reducing single-use plastic waste and promoting a greener lifestyle. The production process for these products is simple and energy efficient. Bamboo is cut, boiled, dried, then polished and treated for antibacterial protection using natural methods such as steaming or soaking in bamboo vinegar. As a result, the products are not only safe for human health, but also fully biodegradable after disposal. Many small workshops have grown into sustainable production chains, creating jobs for local communities. Therefore, bamboo is not just a raw material, but a symbol of the green circular economy, a connection between nature, people, and the future. A portion of bamboo waste is used to produce bamboo charcoal. This type of charcoal has excellent odor-absorbing properties and can be placed in cars or rooms for deodorization, as well as used for water filtration. Everything can be utilized, with different groups taking charge of each stage. During the production of bamboo charcoal, a byproduct known as bamboo wood vinegar is also created, which can be used in medicine or as a natural termite repellent. In the eyes of many, bamboo was once seen as a humble material, something tied to thatched roofs and small village bridges. But under the hands and imagination of humankind, its value has been redefined. From a slender stalk, it has become the foundation for roads stretching out to sea and the scaffolding that supports skyscrapers in modern cities. The miracle lies not only in bamboo's strength, but in the belief that such a simple material can achieve the extraordinary. In an age dominated by machines and alloys, bamboo reminds us that true innovation does not always come from discovering something new, but from seeing the familiar in a new light. This flexible adaptability proves that bamboo is not just a cultural heritage, but a material of the future, a symbol of innovation, sustainability, and respect for nature in our modern industrial world.